The next presenter is Andrei Kovalchik, and his topic is Openshift Virtualization. It's really interesting how not to, let's say, over provision our systems and to have bare metal, then virtualization, and then the container platform, but rather than to put on the bare metal the container platform and side by side with containers to have also virtual machines. So, Andrei, the stage is yours.
Thank you. Good afternoon. Stilan, can you confirm that you can hear me?
Yes, we hear you.
Thank you. I will share my screen. So, Openshift Virtualization, that's my topic. Why Openshift Virtualization? This is the most important topic that right now on Openshift, when you install it on bare metal, you can run together containerized application and virtualized application. But as you see here on this picture, VM virtual machine runs inside container. This is a new approach. So as you see, you will install Openshift on bare metal on physical machine, and then you have Linux Core OS. This is a new Linux. We bought this company. And on top of it, you will install Openshift. No hypervisor level. Why? Because we are using virtualization that is embedded in our Linux. This is important that right now you can run it everything on Openshift. So what you can run virtual machines, not only based on Linux, not only based on RHEL, but also based on Windows, because typical problem or challenge when customers wanted to deploy on top of Openshift containerized software, it works okay, but sometimes they are using a legacy frameworks like .NET, not .NET Core, but pure .NET framework. Right now, they are able to deploy on Openshift virtual machines that are based on Windows, and inside this VM, they can run any legacy .NET frameworks. And what is important, because a virtual machine that is treated in the same way like containerized application. So it means you can exchange information between containers in VMs, but it runs on the same platform. So you are using the same network. In Openshift, you have software-defined network, so you can easily connect microservices with legacy applications. So this is the new trend. One single platform for any load. So for VMs, for services, and also for containerized application. So traditionally, like was in the past, so there was a hardware, on top of it, there was a hypervisor installed. Then you can run RHEL, Linux, Windows, any other flavors of Linux. And if you need to run container, then you need to install some container platform. So this is like Openshift. In the modern approach, you can have just a bare metal, and on top of it, you can run both RHEL-based and containerized software. What is important, this Openshift is using a socket-based subscription, but that one deployed on hypervisor is using a core-based subscription. So the price is very, very different. This one is much cheaper, but there are also some limitations. So you cannot have a bigger server than 64 cores for one subscription, but you can add more. So on one single platform, you can run VMs. You can see on this picture on RHEL, but also you can run Windows-based VMs. You can run containerized application like Java, .NET Core, and PHP and others, and databases. But also, if you want to run in your environment, for example, on test on dev, to just validate the database that is not containerized yet, right now you can run it inside container. So this is a new approach. We support this kind of virtualization only on bare metal. We do not support it on nested virtualization. So this is a prerequisite. But what is Openshift virtualization? This is a containerized virtual machine, but behind the stage, it utilizes Kubernetes. So it is using Openshift features. It is using a compute node, like you see here. It is using a network, internal software-defined network, and of course, you can use storage that is provided for both for containerized software and for virtualized. Here you can see some applications that are deployed, not only microservices, but also like a fat containers or some services available on top of Openshift. So what is Openshift virtualization? This is a KVM-based virtualization hypervisor or virtualization. It is completely managed, scheduled, deployed by Kubernetes. So no hypervisor level, because it is using a kernel-based virtualization. So every single VM, it is running inside pod, right? So it has a connection to software-defined network. You can, of course, external to VLAN and other networks. Also, it is using concept of PVs, persistent volume plan, like you have in Kubernetes. So you can treat VM from like a hybrid solution because it is a stateful, it contains the whole operating system. You can deploy legacy application, but you can connect network and storage in the same way like for any kind of containerized application. What is a KVM? KVM is a very old proven hypervisor for Linux. It's based on the kernel. So it is using kernel, right? So you don't need to have an additional layer. You can run virtual machines directly on open operating system level. You see, KVM, it's more than 10 years. Our traditional virtualization, Red Hat virtualization, it's based on KVM. Also, OpenStack, it's based on KVM. Some other hypervisors or vendors, they are using KVM. IBM in mainframe also, I think Nutanix is using KVM-based virtualization. So this is a new solution to run both containerized applications and also virtualized. You see, this is a Red Hat CoreOS operating system. This is crucial to understand that your VM must run inside container, because Red Hat CoreOS, it's not a general purpose RHEL. It's an operating system, it's Linux that is dedicated to run containerized load. This is very secure because you cannot install anything on this Linux. With one exception, you can run containers. So if you want to install library, you want to add some drivers, you want to add RPMs, you cannot do this with Red Hat CoreOS. This is immutable. You need to run it on top of it in containers. So from this point of view, it's very secure Linux because you will follow the configuration that it's available on Red Hat webpage or Red Hat portal. Then you can run any kind of containerized software. So this is using a Kubernetes approach. You see on the right-hand side screenshot from the Openshift console. Typically, any containerized application is presented like a circle. VM has a different shape, but this is just a shape, just to show to admin that this is not a container, it's VM, right? It's virtual machine. You see the logo of Fedora. So you can easily use internal network, so like a service inside Kubernetes, and you can easily expose this VM outside of Kubernetes using routes. So internally, you can connect pod containerized application to virtualized. You can connect virtual machine to pods, virtual to virtual machines. So this is very easy, and you can easily set up networking because it's a software-defined network. How to manage it? You have a dedicated section in Openshift Container Platform GUI, so you can easily create virtual machine from scratch, or you can use a template base. So as you see here, you can run Windows, right? So you see operating system here, and you can see also some pre-configured data like IPs, etc. So you have a section for pods and dedicated section for virtualization. All others options are shared between pods and virtualization. So let's imagine that you want to create new VM. You can start it from here, create virtual machine, right? You can start with wizard, or you can use a YAML file. Wizard will guide you like by hand, step by step, to create new virtual machine. You don't need to start from scratch. You can connect to hypervisor like VMware or Red Hat virtualization, and you can import it. You can import machine by machine, or you can use a batch importer. So it means you will connect to hypervisor server, and it will detect VMs, and it will import it. So this is very, very useful. So this is a screenshot from the wizard, right? So you can set the proper booting resource like Pixie boot. Then you can add, some T-size pre-configuration, like it's not T-size, T-shirt size configuration, like small L or XL, like tiny. So it is very small machine, 1 vCPU and 1 gigabyte, small 1 vCPU and 2 gigs, etc., etc. So you can use predefined templates like flavor, right? So this you can of course configure it. You can add disks using PVs. Then you can configure networks for your virtual machine. So from this point of view, it looks like any hypervisor, because this is what you need for a virtual machine to run it, right? Then you can use also other virtual networks. We are using Multus because on pure Kubernetes, you can use the just one port 80H0. So for this reason, we implemented Multus. Then you can also add storage. So you can add, because it's a bare metal, you can add SATA disk, you can SCSI, but also we support container storage interface, CSI, that it's provided by software vendors, but still even not software, hardware vendors, but still you need to deploy some software like a bridge between Kubernetes and the hardware. So then you can easily connect this CSI, container storage interface, to your virtual machine. So for example, you can add CD-ROM even, and you can create a virtual machine directly on Openshift. You can power it on or not. So you can easily import VMs. As I said, you can use VMware or Red Hat virtualization for this, and your virtual machine will be imported and will run inside Openshift. You can see all details about your virtual machine. The same metrics are provided for pods like for this virtual machine. So you see CPU utilization, memory consumption, file system, and network transfer. Everything is point. You have also direct access to your console. You can see network interfaces. So this is a single common dashboard for both for containerized application and for virtual machines. You can easily control it. So and you see you have a actions provided for your VM. You can easily migrate. Of course, you can clone virtual machines, stops, restart. You can label, so group for grouping purpose, for example. This is also available just from graphical GUI. You can have access to console, right? VNC, via VNC or via serial console. This is easy, so you can log in and you can execute commands in the terminal window. This is very useful. Metrics. Everything is collected and aggregated. So you can easily monitor, you can set up using some Prometheus alerts. You can set up alerts. For example, if your machine is using more CPUs, or you can set up thresholds. So summary is provided for you, like a 1, 6, and 24 hours period. So you can easily control it. So on one platform, you can have both containers and the same system, the same monitoring systems. And this is in Prometheus, right? So all details are seen here via dedicated Prometheus. By the way, it's part of Openshift. You don't need to install a separate. All data are collected from pods, from the Openshift clusters, from software deployed on Openshift, and are visible in the Grafana GUI, via Grafana GUI. So this is all metrics also are predefined, and you can easily just choose from the GUI a proper metric, and a proper graph will be displayed for it. Storage. So you can easily add storage like iSCSI, but I mentioned already this container storage interface drivers. So typically a big storage vendors provide this for Kubernetes, for Openshift. We have our own storage for Openshift container platform. This is it, Openshift container storage. So you can deploy it on bare metal, you can deploy it on this, but right now we are talking about virtual machines. So you will need dedicated at least 3 nodes to deploy this container storage. And it can utilize disk, embedded disk, because it is using a software replication. By default, it is replica free. If you want to migrate your VM between nodes, you need to have a access mode with RWX. So it means that many nodes can read and write data, many worker nodes, so Kubernetes clusters. RWX is provided by Openshift Container Storage. So this is important from this. So why Openshift? Typically because of money, because you can save money and you can avoid hypervisors. So you will simplify the architecture and you will run both containers and virtual machines on the same platform, and you will orchestrate it by Kubernetes. So consistency. Still, new applications, if you even containerize it, need connections to traditional or legacy applications. Right now on Openshift, you can run both. For example, for test cases, you can run some applications that are needed for your test scenario that are not containerized yet, of course, like, for example, written in traditional .NET framework and that are running on Windows Server. Right now, you can easily provision such a VM on Kubernetes, connect to your project or run it inside your project. So consistency and consistent management, consistent platform. Also, you can use more OpenShift because, as I said, there is a different flavor of subscription, which is socket-based, so it's much cheaper than core-based. And you can motivate your your team to improve Kubernetes skill. By the way, Kubernetes, it's the most desirable right now job in the world. People are looking mostly for Kubernetes. So this is important that you can improve it. And you can modernize operational model right now. So this is a common platform for a new DevOps team and for your SRE engineers. So this is Openshift Virtualization. There are some prerequisites for your machines, not so complicated, but you need to follow the manual if you want to run a virtual machine. And one sentence from the customer side. We visited it like 3 weeks ago. The customer decided to run OpenShift on bare metal because the current installation that runs on top of VMware, it's fully occupied. So, and they don't want to, they decided not to extend the current virtual platform, but to choose OpenShift on bare metal. From the first phase, they will use just for containerized load, and later they will start to think about some possibilities to run also virtual machines on top of OpenShift, because right now there is a chance to have a common platform for both virtual machines and containerized. Not just at the hypervisor level, but for example, just for a test for developers. So if, because as I said, there are many still legacy applications that cannot be containerized, but for tests, it's much easier to run it within the same network using the same storage like in Kubernetes, because OpenShift gives you these possibilities. So that's all from my side. Thank you very much.